98% of the universe could be dead silent, and that silence might be the most terrifying answer to a question science still can't solve. If aliens are out there, why haven't we heard a single whisper from them? In 1950, physicist Enrico Fermi asked one simple question over lunch that still haunts scientists today. Where is everybody? That question became known as the Fermi paradox, and it's one of the most unsettling puzzles in modern science. Here's why it matters. Our galaxy, the Milky Way, contains an estimated 100 to 400 billion stars. Scientists estimate there could be over 2 trillion galaxies in the observable universe, based on deep field imaging from the Hubble Space Telescope. That means the number of stars in the universe is larger than every grain of sand on every beach on Earth combined. Now factor in planets. Data from NASA's Kepler mission and the ongoing Transiting Exoplanet Survey satellite, known as TESS, has confirmed thousands of exoplanets so far, with thousands more candidates awaiting confirmation. Based on Kepler's findings, astronomers estimate that on average, every star in our galaxy could host at least one planet. That means there could be hundreds of billions of planets in the Milky Way alone, and a portion of these fall inside what's called the habitable zone, the region around a star where temperatures could allow liquid water to exist on a planet's surface. Liquid water is considered the single most important ingredient for life as we understand it. So here's the math. Even if only 1 in a million of those planets developed life, and only 1 in a million of those developed intelligent civilizations capable of building technology, the numbers still suggest we should not be alone. Statistically, the galaxy should be teeming with civilizations. Some of them should be millions of years older than us. Some of them should have already mastered interstellar travel, or at least interstellar communication. So why is the sky silent? Since 1960, scientists have been actively listening. The SETI Institute, short for the Search for Extraterrestrial Intelligence, has spent decades scanning the skies for radio signals that could indicate intelligent life. In 2015, Breakthrough Listen was launched, a scientific initiative funded by the Breakthrough Prize Foundation, dedicating over $100 million to searching for techno-signatures using some of the most powerful radio telescopes on Earth, including the Green Bank Telescope in the United States and the Parkes Telescope in Australia. The result, after all this time and all this money? Nothing conclusive. No confirmed signal. No verified contact. Just silence. This silence is exactly what makes the Fermi paradox so disturbing. It's not that scientists haven't looked, it's that they have looked, extensively, with cutting-edge instruments, and found nothing that holds up to scrutiny. There have been strange moments. In 1977, an astronomer named Jerry Eman detected a powerful narrowband radio signal using the Big Ear radio telescope in Ohio. The signal was so unexpected and so strong that he circled it on the printout and wrote "Wow" next to it. It became known as the "Wow" signal. It lasted 72 seconds and was never detected again, despite repeated searches of that same region of the sky. To this day, its exact origin remains unexplained, though most scientists lean toward a natural astronomical explanation rather than an artificial one. That's it. That's the closest thing we have to an anomaly in over 60 years of searching. One unexplained 72-second blip. So scientists have proposed several explanations for why the universe appears empty, and some of them are deeply unsettling. The first is called the Great Filter, a concept introduced by economist and researcher Robin Hanson in 1996. The idea is simple but chilling. Somewhere along the path from lifeless chemistry to a civilization capable of spreading across the stars, there exists a filter, a stage so difficult to pass that almost no civilization makes it through. The terrifying question is not whether this filter exists. It's whether we've already passed it, or whether it's still ahead of us. If the filter is behind us, that would mean the emergence of life itself, or the jump from simple to complex cells, is so statistically rare that it may have only happened successfully here on Earth. That would make us cosmically unique, but also terrifyingly alone. If the filter is ahead of us, that's the version that keeps scientists up at night. It would mean every civilization that reaches our current level of technology eventually destroys itself before it can expand into space. Nuclear war, engineered pandemics, uncontrolled artificial intelligence, climate collapse, or something science hasn't even conceived of yet. Think about where humanity stands right now. We developed nuclear weapons in 1945. We've built artificial intelligence systems that are already reshaping economies faster than governments can regulate them. We're altering our planet's climate at a pace that outstrips natural cycles by orders of magnitude. If the Great Filter is ahead of us, we may be approaching it right now, in this century. The second major explanation is called the dark forest hypothesis, a concept popularized by science fiction author Liu Cixin in his novel The Three-Body Problem, though the underlying logic draws from real game theory principles. The idea goes like this. The universe is like a dark forest at night. Every civilization is a hunter, and every hunter has to stay silent, because any other hunter they encounter might be more advanced, more dangerous, and might see them as either a threat or a resource. In this scenario, advanced civilizations don't reach out because broadcasting your location to the universe could be an extinction-level mistake. If this hypothesis were true, the silence we hear isn't because no one is out there, it's because everyone out there has learned that staying quiet is the only way to survive. The third explanation is called the zoo hypothesis, first proposed by MIT radio astronomer John A. Ball in 1973. This theory suggests advanced civilizations already know we exist, but they deliberately avoid contact, similar to how humans might observe an animal in the wild without interfering with its natural development. Under this theory, Earth could be under a kind of cosmic non-interference policy, waiting for us to reach a certain level of maturity before any contact is made. Then there's the simplest, and in some ways the most humbling explanation, the rare Earth hypothesis, developed by paleontologist Peter Ward and astronomer Donald Brownlee in their 2000 book, Rare Earth: Why Complex Life is Uncommon in the Universe. Their argument is that while simple microbial life might be common in the universe, complex, intelligent life requires an extraordinarily specific set of conditions. Earth has a large moon that stabilizes its axial tilt, preventing extreme climate swings. Earth sits in a stable orbit around a stable, long-lived star. Earth has a molten iron core that generates a magnetic field, shielding the surface from deadly solar radiation. Earth has plate tectonics, which recycles carbon and regulates the climate over geological time. Jupiter's massive gravity acts like a cosmic vacuum cleaner, absorbing or deflecting asteroids and comets that might otherwise devastate Earth. Remove any one of these factors, and complex life as we know it might never have evolved. If this hypothesis is correct, it means intelligent life isn't just rare, it might be almost miraculously rare. Some estimates based on this model suggest that complex, technologically capable civilizations could be separated from each other not just by trillions of miles, but by hundreds of millions or even billions of years in time. Two civilizations could exist in the same galaxy and still never overlap, simply because one rose and fell long before the other even began. And that brings us to the scale problem, which might be the most underrated part of the entire paradox. Even if intelligent civilizations exist right now, in this moment, distance alone might make contact functionally impossible. The nearest star system to our own, Alpha Centauri, is about 4.24 light-years away. That means light, traveling at roughly 186,000 miles per second, takes over 4 years just to reach it. Our fastest spacecraft ever launched, Voyager 1, has been traveling since 1977 at approximately 38,000 miles per hour, and it would still take Voyager over 70,000 years to reach that same star system, if it were even headed in that direction, which it isn't. Now scale that up to the size of the Milky Way, which measures roughly 100,000 light-years across. A radio signal sent from the center of the galaxy right now would take 25,000 years just to reach Earth. If a civilization on the far side of the galaxy sent a signal today, none of us alive would ever know, because it wouldn't arrive for tens of thousands of years, and by then, that civilization might not even exist anymore. This is the piece most people miss when they think about the Fermi paradox. It's not just a search problem, it's a time problem. We're not just looking across space, we're looking across time, through a universe that is approximately 13.8 billion years old. Based on measurements from the Planck satellite and observations of cosmic microwave background radiation, human civilization, in its current recognizable form, is roughly 12,000 years old. Radio technology, our only method of reaching across interstellar distances, has existed for barely over 120 years. In cosmic terms, we've been shouting into the void for the blink of an eye. If another civilization was listening a million years ago, or will be listening a million years from now, we would completely miss each other, even if we were neighbors in the same galaxy. There's also a newer, more modern theory gaining traction among researchers, sometimes called the Great Silence through digital transition. The idea suggests that once a civilization becomes advanced enough to build artificial intelligence, it may naturally transition away from physical exploration and communication altogether. Instead of building massive radio arrays or spacecraft, an advanced civilization might turn inward, building simulated realities, digital consciousness, or self-contained virtual environments that require no physical expansion at all. If that's the natural trajectory of intelligence, then advanced civilizations might not be silent because they're dead. They might be silent because they simply have no reason to reach outward anymore. This theory intersects with real, current developments happening on Earth right now. As of the mid-2020s, artificial intelligence systems have advanced faster than most scientists predicted even 5 years ago. Some researchers in the field have openly speculated that once AI systems reach a certain threshold of capability, they may fundamentally reshape what civilizations prioritize, moving away from physical expansion and toward computational and digital existence. If that shift happens to every sufficiently advanced species in the universe, it could explain why we don't see megastructures, why we don't detect Dyson spheres, and why the sky remains quiet, not because life is rare, but because expansion itself may not be the natural endpoint of intelligence. Speaking of Dyson spheres, this is one of the most fascinating technosignatures scientists actively search for. Proposed by physicist Freeman Dyson in 1960, a Dyson sphere is a theoretical megastructure that a highly advanced civilization could build around its star to capture almost all of its energy output. If such a structure existed, it would block a specific, detectable amount of a star's light while still radiating waste heat in the infrared spectrum. Astronomers have used data from the Wide Field Infrared Survey Explorer, known as WISE, to search hundreds of thousands of galaxies for these infrared signatures. So far, no confirmed Dyson sphere or megastructure has ever been detected. Some candidates have caused excitement over the years. In 2015, astronomers using data from NASA's Kepler mission detected unusual dimming patterns around a star called KIC 8462852, later nicknamed Tabby's star, after astronomer Tabetha Boyajian. The star's brightness dipped in irregular, unexplained ways, dropping by as much as 22% at certain points, far beyond what a planet passing in front of it could cause. For a brief period, some scientists speculated this could be evidence of a partially constructed megastructure. Follow-up studies, however, using data collected between 2016 and 2018, found that the dimming was more consistent with an uneven cloud of dust orbiting the star, not an artificial structure. The mystery excited the public for years, but the natural explanation ultimately won out. This pattern repeats throughout the search for alien life. Exciting anomaly, global attention, careful follow-up study, natural explanation, every single time. And that pattern itself raises an uncomfortable question. What if there simply isn't anything out there to find? At least not within our current technological reach. Or, what if the search itself has been looking in the wrong way entirely? Traditional SETI research has focused heavily on radio signals, since radio waves are relatively cheap and easy for us to produce and detect. But an advanced civilization, thousands or millions of years ahead of us technologically, may not use radio waves at all. It would be like trying to detect a modern internet company by searching exclusively for smoke signals. We might be listening for the wrong kind of signal entirely, using instruments that are, relatively speaking, primitive. This is part of why newer research initiatives have expanded beyond radio waves. Scientists are now using the James Webb Space Telescope, launched in December 2021, to analyze the atmospheric composition of distant exoplanets, searching for what are called biosignatures, chemical markers like oxygen, methane, and phosphine that, in combination, are difficult to explain through non-biological processes alone. In 2023, researchers detected carbon dioxide and methane in the atmosphere of an exoplanet called K2-18b, located roughly 120 light-years from Earth, and some studies suggested a possible detection of a chemical called dimethyl sulfide, which on Earth is only produced by biological life such as marine phytoplankton. This finding generated significant excitement, though the scientific community has stressed that these results require further confirmation, and phosphine or dimethyl sulfide detections in other studies, including similar claims about Venus's atmosphere in 2020, have historically been walked back or heavily disputed after additional analysis. This is how real science works. Bold claims get tested, challenged, and either confirmed or discarded. Nothing here has been definitively confirmed yet, but the search methods themselves represent a genuine leap forward from radio telescopes alone. So where does this leave us? Standing on a small rocky planet, orbiting an unremarkable star, in an ordinary spiral arm of an ordinary galaxy, among trillions of other galaxies, having searched the skies for over 60 years with radio telescopes, infrared surveys, and now atmospheric chemistry analysis, and having found absolutely nothing definitive. Maybe we're early. Maybe intelligent life takes billions of years to develop reliably, and we happen to be one of the first civilizations to reach this stage in the entire observable universe. Maybe we're rare, and the specific combination of conditions that created us, a stable star, a stabilizing moon, plate tectonics, a protective magnetic field, and billions of years of uninterrupted evolutionary time, is so unlikely that it may have only happened once here on this planet. Maybe we're being watched, deliberately left alone under some form of cosmic policy we don't yet understand. Maybe everyone out there has learned that silence is survival and speaking up is a death sentence. Or maybe, and this is the most sobering possibility, the great filter is real, and it's still ahead of us, waiting. Every one of these explanations carries massive implications for humanity's future. If we are alone, then every decision we make about protecting this planet, its climate, its resources, its biodiversity, and its people matters infinitely more, because there may be no backup, no second chance, and no one else coming to carry the torch of consciousness forward if we fail. If we are not alone, then somewhere out there, potentially right now, another civilization is asking the exact same question we are, staring up at their own night sky, wondering if anyone else is looking back. Enrico Fermi asked his question over 70 years ago, and in that time, we've built telescopes powerful enough to see galaxies formed billions of years ago, spacecraft that have left our solar system, and instruments sensitive enough to analyze the chemical makeup of atmospheres light years away. And still, the answer to his simple question remains exactly the same as it was in 1950: silence. So here's what I want to know from you. If you had to choose one explanation for the Fermi paradox, which one do you believe is true? Are we alone? Are we early? Are we being watched? Or is the great filter still ahead of us? Drop your answer in the comments, and if this made you think differently about the universe tonight, follow for more deep dives into the biggest unanswered questions in science.